Well, good afternoon once again. I want to welcome you back from your holidays. For those who are just joining in, I was trying to update something here as we plan to start our lesson. And this is a senior to mathematics lesson from the holistic learning platform. We always have lessons during the holidays. And this time round, we planned for you about 2 weeks. And we are going to have a number of lessons. Mathematics is one of them. And I will assume all of you are in the WhatsApp group for the class. And that is where we always post the timetables and also the notes if there is anything the teacher wants to communicate to the students. My name is Masave Erisa. I work with Bali Secondary School and I teach mathematics and ICT at the same school. I also work with the holistic learning platform where we interact with students virtually. And probably that is it for now. I want to welcome you once again, and I want to remind you that I'll be working with about 3 people here. And we expect you to have some maximum attention when it comes to present. In case you want to say something, always put up the hand and you'll be given a chance to say a word or two. Before we start, I want to find out some of the students who are here. You will just let me know of your name and probably the school where you're coming from, such that we get to know each other. And you'll type in the chat. I'll start by typing mine, such that we get to know each other. Mine is, that is the name. I work with Bali Secondary School. And probably you would join from there, type your name and your school, such that we get to know each other as the lesson continues. Krista, I think, was that, that is Taiba International. Is that a spelling error or that name is written as Krista? Then we have Indices S, Jessica, you're most welcome. And from Taiba International School, you're also most welcome. We have Indices S, Abigail Joy, and probably others that will be reading as time goes by. Gloria from Indices S, Eunice. And Eunice, I'm waiting to read about your school. Hey, Eunice, I don't know which school is that. You're most welcome as well. That is Sabrina from Indices SS, Ferista from Budo SS, you're most welcome. Ferista and Sabrina. Then we have Joshua Bulova Christian High School, you're welcome as well. Indices SS, Priska, you're also most welcome to the lesson. And we have who else here? Yes, this is Sarah Namtebi, and this is from Taiba International School. And Eunice is from Indices. Sarah Namtebi is from Taiba International School. And probably others as they come. This is Mbaleses in Phoenix. This is Abel. Abel, I will have to rename your device such that it can read your name. Phoenix, Note 10. And this one cannot hear because he has not logged in well. This is Barbara. This is another hard name to pronounce, but from Indices S. This is, how do you pronounce that name? Vabra?
Savan Bragatash.
Can I know your name? Just remind us your name. This one is too long. Okay. Is this the name?
Tash.
Tash. Well, you're most welcome, Tash, from Indices S. It's been a while since we last interacted. It is who?
Thank you, sir.
Hope the Indices S team is good. I have seen Budo, I've seen Indeje, Taiba International School, I've seen Balises. You're all most welcome. So we'll be starting, but let the names of the school continue in the chat such that you get to know who is here and you get a chance to probably know if your friend is here or not. So this is a math lesson, like I told you, and we will be making a revision as we're going to see, and probably we'll get to know if you've covered that or not. If you've covered, it will be a revision. If you've not covered, then we'll develop the concept as the syllabus guides us. That is Tracy from Balises. Good. So this afternoon, we'll be talking about a certain chapter that I'm going to display later on. But before I display the chapter we were going to work with, I felt you needed to see what is expected this term. You're going to go to Senior 2, term 2, this coming month. Not actually the coming month, this very month, depending on your schools. And this is what we expect to cover this term. And as holistic e-learning platform, we always give students a feel of how next term will look like, such that when they go back to their schools, it is always not very hard because they would have interacted with these chapters a little earlier compared to other students who will be in the same school. So this is what we expect students to have cover this term, depending on your schools, if you covered all the term 1 activities. And this term is term 2, and we are expected to cover the following. I'll just annotate such that you're able to see those chapters. You're expected to cover varieties and regions, depending on your school, if they finished all the chapters of Senior 2, term 1. We expect you to go back to Algebra 2, then similarities and engagement. We'll also cover circles and rotations this term. So for those who want to read ahead, I would encourage you to get those book tools open and read through before you go back to school. You can pick a certain chapter here. It could be similarities or enlargement, such that you read a little bit ahead. We just vectors and translation, vectors and translation. Someone has covered vectors and translation, so you still have more to go, depending on your school. It depends on which school you're coming from and how they are covered. But we expect you to be going to term 2, and these are the chapters we are going to find there. So I want to find out how people have covered their term 1. Probably. I'll be displaying that later on, but probably you've covered some of these chapters. So I felt it is important for you to know what you're going to cover this time. So this afternoon, as a holistic e-learning platform, we are going to review this particular chapter, which is the last chapter in term 1. So you could have covered it wherever you are, or you've not covered it. If you've covered it, well and good. If you've not covered it, we are here to see if we can help you get a feel of how it looks like. And that is numerical concept 1. You'll find numerical concept 2 ahead. But for now, we'll have to look at numerical concept 1. This is what you were supposed to have covered towards the end of this term. And if you didn't cover, we'll proceed from there. Yes, Tash, you have something to say?
So for us, we are still on mappings and relations.
Mappings and relations. Yeah, that is quite unfortunate, but then you have just 3 to go, so you're not bad low. So when the coverage is stepped up very fast, then you'll also get there. Who else wants to share the chapter they have covered? Tash, you may put down your hand. Jaden.
So first, we're just on vectors and translation.
Screen in progress. In progress.
Sorry about that. Vectors and translation, you're not very far away. So probably when you go back, the teacher can cover up very fast and you get there. I want to check because of the hands. Felista, maybe you're the last one. I'm going to display such that everyone ticks what they have covered. Felista?
So for us, we have covered the first 3. We had not yet started numerical concept 1.
That one is good. I'm going to launch this poll. You'll see these chapters on your screen. Just tick the chapters you've covered, if you've covered any of them. And I don't know if you can see that poll. I'm going to put down my screen such that you're able to see it. People have covered business arithmetics, timetable. Yes, majority has covered that. Only one person has covered numerical concept 1. Graphs, majority 4. 4 people have covered graphs. Vectors and transition, still 4. Let's not use the videos. If you're very sure, if you're not sure of where you are, Priska, is that a bet? You may have to put down your video for a while. If you're not in a good background, just put on your video if you're sure of the background. I'm still waiting to see the coverage here. Yeah, numerical concept 1 is not fairly covered. I'm going to introduce it here such that we have covered topic 1 and 2. Tracy, you may have to, there is a poll that is on the screen. Just select the topics you've covered from the screen. Anyway, I'm going to end this poll such that we can proceed. Yes, let me relaunch it such that those who are not seen can see it.
And
anyway, we'll have to proceed. But that is a good check. If you've not covered, then you'll have to look for the books and try to read ahead. It's not bad to always read ahead of the teacher. And we always encourage that. I'm going to stop everyone's microphone such that we proceed. And for those who have covered, well and good. If you've not covered, we'll talk about it. But in term 2, we expect you to cover inequalities and regions. Write it down such that you can read about it. Then algebra 2, we'll get to see what belongs here. But in algebra 2, you'll look at quadratic equations, and a number of things. Then similarities and enlargement, you'll see this, but this topic 7 borrows the idea of the primary concepts that we had studied in primary, P7. Circles are obvious. Here we'll look at majorly how to get the circumference and the area of the circle, and sometimes getting the area of the shaded part where they give you a circle and probably they put a rectangle inside. We're supposed to get the area of the shaded part. Then in every case, there will be an activity of integration such that they score you. And I'm also interested in seeing how people performed here when you went back to your schools. I'm going to assume you go to the average. If you did 3 activities of integration, there is that average. And that average should be a 3, it should be a 2, it should be a 1, it should lie between that. So I'm going to be interested in the average. I want to know, did we get some people who passed well or not?
There are no hands up.
My boy.
Sorry about that. My network slowed down here. I pray it gets back quickly. Krista, you have, I see your hand is up. May I know? Sorry about that. I pray that doesn't come back again. My network is slowing down here, but we're going to proceed. Numerical concept 1, indices and logarithm, and we're going to pick specifically indices. We're going to revise indices this afternoon. We will see some of the principles in indices. Majorly, these principles are primary principles that we looked at in P7, P6 for some students. So we'll remind ourselves on what to do when you're given what. Later on, we'll apply those laws of indices to solve some problems, and that is where the lesson will end. So allow me proceed for those, and we are picking this numerical concept 1, indices and logarithm. Now, what is going to happen is that for those who have not covered, in most cases, this is how we handle this. In senior 2, you're going to cover indices majorly, and if time allows, you will also check on what? Logarithm. But for now, as you go back, put in mind, it is majorly indices that you're going to cover, and logarithm will come later on, or if the teacher is very fast, then you can combine indices and logarithm at the same time. So when you go there and maybe logarithm is not talked about, it may be because of time. So that is what we'll be covering this afternoon, and specifically we'll be talking about indices, and for those who are writing, it is indices and the competence is here. The learner understands and uses indices and standard form. Now, standard form comes from indices, and once we understand indices, we'll be so good to go. So make sure you understand indices, especially the principles. Those principles are called laws. There are 5 major ones that we'll talk about here, and later on you will see how to apply those laws of indices to solve problems. Then in the end, an activity of integration will be presented to you that applies those laws of indices. Hope you remember them very well and you score a 3, like I have seen some people here scored 3 in their chapters of integration. So here are the learning objectives. Maybe to just find out if people are able to read, someone can put up the hand and read for us what is here, such that we move very fast. But this is what we expect students to learn in this chapter. May I hear from Patricia?
Learning objectives. By the end of this chapter, the learner should be able to 1. Give approximate answers to calculations. US. Then B. Write numbers to a given number of significant figures.
Okay, the next one, probably I would have to display all of them. Yeah.
C. Differentiate between significant figures and decimal places. D. Express numbers in standard form. E. Identify base number and index. F. State and apply the laws and indices in calculations. Then G. Use a calculator to find powers and roots.
All right, thank you so much, Patricia. The U and S, the K, those are key terms here that are used by the teachers. One is for knowledge, one is for skills, and others. So you'll get to know that probably with time. But this is what we expect from students who would have covered such a chapter. You must be able to give answers which are approximate to calculations. For example, if I told you to divide 1 out of 3, which answer would you give? Probably you may use a calculator here and get those answers. And you're able to write a given number of, you're able to write a number to a given number of significant figures. You'll also get to see that. For those who have covered, you know what significant figures means. It is abbreviated as SF. And the difference between significant figures and decimal points, I can't start all this for now. And then standard form, picked direct from primary, and identify base number and index number. Still, this is knowledge that is picked straight from primary and brought here. And those laws of indices are very important, like Patricia read through here, and how to apply them when you're performing calculations. So take that screenshot and know that this is what we expect of you. But because this is revision, we may not entirely exhaust all this. We'll just talk about the basics of indices and quickly apply those laws of indices. Significant figures in physics. Yes, we have significant figures in physics as well. So if you've ever covered them in physics, then those are the ones. Someone can't hear. If you can't hear, then try to log off and log on again. So we expect you to learn all this by the end of the lesson, by the end of the chapter. But because this is a revision, I'm picking indices and we're going to make a revision about the indices. And I will start by reviewing the laws of indices. The first law of indices is going to be displayed, but before we talk about the laws of indices, you need to know something, and this is what I want you to know. as we continue, we are going to write things like maybe 5 to power 4, like this, and 5 to power 4. This one is 5 and the 4 is up. This is read as 5 to power 4, and 5 becomes the base and 4 becomes the power. So if you get to see something like that, then this is going to be what we are going to look at. It's a full topic in mathematics called indices. So take note, the upper one is a power and the lower one is a base. So if you read well the objectives, you should be able to identify the power and the base. So I have some guiding hint here for which is Roman number 1. It's 1, and I'm talking about 3 to power 5, which is read as 3 to power 5. 3 to power 5 is read as 3 to power 5. And when you see something like this, it means 3 has been multiplied 5 times, and that's why we have 2 to power 5. And later on, you will see what 3 to power 5 means. And majorly, this is called the index. This 5 here is called the index, or some books refer to it as a power. Then a 3 is a base. So when you see 3 to power 5 in indices, it is read as 3 to power 5, and 3 is the base, 5 is the index, or it is the power. If there is something in the chat that I have to talk about, probably let me know. My co-hosts, I may not keep checking there if there is any burning question or something I need to clarify on. So majorly that is it in line number 1, and we will see some of the rules. Someone had written very good for 5 to power 4. I tried to write it in expanded form, and I'll quickly bring the rows of indices. Now, this is what I expect you to write. For those who are writing, the first one is this. If you're given numbers that have the same base, we always add those powers, and later on we will see what this means. If you're given a question that has this kind of application, are you able to recall that if the base is the same, we add the powers? For example, we may have something like this, 3 to power 5, and it is being multiplied by 3 to power 2, like that. So literally, if you don't, if you have time, you can write 3 5 times, then you multiply at once. I believe this is too long. Like that, 5 times, then you multiply it by 3 2 times, like that. So that means you're multiplying 3 1 2 3 4 5 6 7 times. Probably if I'm to annotate and we try to cancel that, this is 1 2 3 4 5 6 7 times. So this rule number 1 is telling us that once you just identify that the base is the same, just add the powers. And this one means the base is 3, which is 3, and you always add that base, which is 5 plus 2, to give us this answer as 3 to power 7, and you can get that from the calculator and you will get that exact answer. But if they want you to write the answer in this form, then you have to leave it there. For example, using the same principle, you may be given power 7 like that. You can use that knowledge of law number 1, and someone can give us what can be written here by adding another by show of hands who can give that a try using this rule number 1. If the bases are the same.
Patricia, unmute.
I think it's 2 raised to power 12, 15. No, yeah.
Can I have the hand up? Am I even clear? Because yes, Patricia.
I said I think it's 2 raised to power 15.
And how do you get that?
If the I first got one base since they're all the same, and then
Which is
2, and then you add the powers.
yes, and the powers, the first power is what?
3.
Yes, continue, just do it.
3 plus 5 plus 7.
Plus 7. And this gives us
15.
2 to power
15.
2 to power 15. Yes, that is how we apply that law of indices, the first one. And it means if we have the base which is the same, always add the powers. M and N are just powers to A, and N is just the other power. So M can be 3, N can be 5. So if you get such a problem, then always get to know what to do if the base is the same. I saw Tash's hand up, probably I need to put some other one here such that another person can try. This is 7 to power 3 has been multiplied by probably 7 again to power 1 multiplied by 7. You may be given something like this, 7 to power maybe 6, like that. Sometimes they can even divide it by something, but I've not talked about division. I can't bring in that. Tash, your hand was up. Probably you can give us, you can simplify for us this. If Tash is not there, someone else can pick it
7
up.
to power 10.
7 to power 10. Yes. 7 to power 10 means you have added 3 to 4, 3 to 1, then to 6. 3 plus 1 is 4, plus 6 gives us 10. And the base is 7. That's why she's having 7 to power 10. That is the most important principle that each student is required to understand when it comes to indices. Once you master that, you're going to solve so many problems in indices that are related to that. The second one is this: when you're dividing numbers of the same base, subtract the powers. And I'll also show you when adding the powers, where does the plus sign come from? Where does the plus sign come from? When you're adding, someone has already answered you that. Like I told you, I'm assuming some people already know this. I'd written 2, maybe 3 times 2, and maybe if this is 2, like that. The answer to this is that you can get 2, multiply it by 2, then multiply it by 2 again. That is 2 to power 3. I don't know if Krista is seeing that. I want to show you where the plus is coming from. And this one is for the first one, to power 3. This 2 power 3 means we are multiplying 2 3 times, and it's here. Then we are going to multiply 2 times for this one here. So I'll also come and multiply. Probably I should use the blue color. 2 2 times, like that. And the answer to this when you use indices is going to be 2 to power 5. 2 to power 5, because we are going to add those powers, 3 plus 2 to give us 5. But if you write it in expanded form, you can see it is 2 multiplied 5 times. 1, 2, 3, 4, 5 times. That's why we have 2 to power 5 when you use indices. So when you use indices direct, you get 5. And how do you get 5? It means you're adding the first power to the second power. This one can be derived when they're introducing this lesson. You'll see why do we write 2 to power 3 and why do we write 2 to power 2, such that you generalize 2 to power 3 times 2 to power 2. The answer is 2 to power 5. And how does that come? It's because they're writing it in expanded form like this, and it is 2 5 times. And how does 5 come? It is 3 plus 2. And a generalization is made that provided this is true, every time we have powers up, you just add them. If you have time, you can write them down and you count the number of times you multiply. If you don't have time, take this, write the base and add the powers, because mathematically it has been proven that it is always true. Provided the base is the same, just add those powers to always give you that answer. For that one who was wondering where the plus sign was coming from, if that can help you. The second one is very important. When you're dividing bases of the same, the numbers of the same base, always subtract the powers. That is a very important principle. Provided you're multiplying, add. Provided you're dividing, if you're given such a question and it is not about indices. What if you're given such a question and it's not about indices? I've not understood that. Provided it is having powers, that is indices, provided it has powers. Provided the question has been given to you, has powers, then it is indices. And in most cases, students confuse indices with fractions. They write, for example, this can be written as, I'm writing this. A student in a hurry can write 3 to the power 5, which is correct. Someone can even write 5 over 3, like that. This is so common when the teacher gives out the exercise. And not the exercise. Maybe those secretaries may fail to write instead, probably instead of writing. My network is too poor. I don't know if you're still able to hear me, but I was emphasizing something here. Can anyone hear me now?
Yes, sir.
Yes, sir.
Okay, I was trying to tell you about some secretaries. When you give them 3 to the power 5 like this, they can't write this in Microsoft Word. For them instead, they'll write 5 out of 3. So sometimes students confuse indices with fractions. Sometimes even those people who type confuse indices with fractions. But just to answer someone's question who was saying, what if the question has been given like this and it is not indices? There is no question that can be given to you like that when it is not indices, provided it has a power. I'm struggling with my network here. provided it is written like this. It has a base, it has a power, whether this is 4 or what. These are indices. So indices comes from the word index, and many of them are called indices. So index, we saw that index is the power, which was 5 here, if you remember very well. So anything that has a power has an index, and many of them are called indices. So don't confuse indices with any other thing. And if it's not given in index form, and they want you to write the answer in index form, then you go ahead and write. If they don't want you to write it, just use the knowledge of indices, but take the answer back to the right answer if the examiner does not want you to use indices. So why do we subtract? Someone has asked already. If we have numbers of the same base and we are dividing them, we always subtract. For example, if we have 5 to power 2, and they are dividing it with 5 to power 1, like that. Those are numbers of the same base, and always subtract the powers, provided you identify that the base is the same, have the powers subtracted. Maybe before I do that using indices, let's demonstrate and get the answer to this. I want to change from 2 to 3. We are going to try that from 2 to 3, changing that from 2 to 3, like that. 5 to power 3 is what? Give me that answer. I want to get that. 5 to power 3 is what? 5 to power 3. We have mathematicians here.
15.
15. 5 to power 3. 5 to power 3 can't be 15. Try
No,
again.
it's not 15.
What is it, Tash?
125.
Yeah.
125. Like that.
So 125.
Yes, next time don't rush. And many students rush with this. It is 5 to power 3 and they get 15. Don't do that. A power means they are multiplying 5, 3.
Excuse me, sir.
Yes, please.
How is it 125?
It is 5, you put in the calculator 5 to power 3.
It is 5 times 5 times 5.
Yes, 5 times 5 times 5, like that. So this is 25 times 5 to give us 125. Alternatively, you can go to your calculator. The calculator has, I am forgetting what is written on that calculator, but it has that option of raising to power. Sometimes a button looks like this. There is a button which has something like that. In other words, you write 5, then you raise, you click on that button and put 3. It will give you 125. Other calculators have x to power n, x to power n, like that. So you write 5 and tell it that it is to power 3. You write 5, press x to power n and put 3. I want to confirm that everyone is getting 125. Alternatively, yes, Faith has 125 in the chat here, which is correct. Why do we subtract? Someone still wants to know. Do we give the answer in expanded form? It depends. Why do we subtract? I'm going to bring that. So this is 5 to power 3, which is 125. And this is 5 to power 1, which is 5 just. And this answer will be 125 divided by 5. The answer is what?
3.
Let's use the calculator. What's the answer? 25 from Faith and Jays. The person is called Jays here, Patricia. I think when dividing, someone is trying to respond. Patricia Nachiki provided. Your hand is up. Let me know why you're putting it up. Patricia. Your hand is up. If you can't unmute, let me know. Or you can type it in the chat. The answer is 25. People are giving me the answer is 25. Patricia, you can now speak.
25.
Or 25 is the answer. So that means that if I divide 5 to power 3, divide by 5 to power 1, my answer is 25. 25 like that. If I do it manually, like from first principles, 5 3 times, divide by 5 1 time, like that. And when you're using indices, they tell us that don't go the long way. Don't go the long way, just subtract the powers. So I'll do like this, 5 to power 3, and my power is 1. So I get 5, which is the base. You can see the base is here. And we subtract the powers, which is 3, subtract 1, and this becomes 5 to power 2. Of course, 3 minus 1 to give us our answer as 25. So you realize that we get back to the same answer that the area long way has showed. So you can choose to go the long way, which is also correct, 5 to power 3, which is James. Jamie, what?
Okay, sorry. For me, I'm asking, what if they've given maybe A, okay, 5 power 3 minus 4, minus 5 power 4. What do we do then?
5 power 3
minus 5 power 4.
Minus 5 power 4.
Yes.
Hey, now this one will get there.
Sir, I meant divide.
Or divide. Eh? If you're dividing that, it's still the same.
So but
That one.
Negative. Do we also just write it like that?
Let me try to see what I can write about that. If you're given that, for example, you write it like this. It's 5 power 3 being divided by 5 to power 4, like that. This answer is also there, though it is too small. This answer is too small. For those who are going direct, you can go direct and give us that answer. 5 to power 3 is what? 125. Then 5 to power 4 is what?
200.
200. And when you divide, what is that answer? Someone has given us 200 as the answer. This is wrong. Eh?
So the answer is
0.6.
Someone has given us a wrong answer. That is not 200. 5 to power 4 is not 200. Who has the right answer? 600 and what?
25.
25.
Yes, 625. And when you divide this, our answer becomes 125 divided by 625. Our answer becomes 0.2. How do you get 0.2 using indices? Now, if you're given something like this is what Patricia had requested, if I remember well, no, Jay's. She had requested that if you're given something like this, how do you solve this in indices? And I'm going to demonstrate that probably here, such that we see how you can have that solved in indices. I'm putting it here, and we're going to use the laws of indices to solve that. The answer, the question is 5 to power 3 over 5 to power 4. This is, the base is the same, we subtract the powers, and this becomes 5, 3 minus 4, which gives us 5 to power negative 1. And 5 to power negative 1, the answer is 0.25, 0.2. If you put this in the calculator, alternatively, for those who understand math, if you're given 5 to power negative 1, they have got the reciprocal 5. I don't know if you remember that, the thing of reciprocal. So this can be written as 1 over 5. And if you get the reciprocal, you can get what? 5 to power negative 1. For those who remember the reciprocal. But if you ended here, you would have passed. You can go ahead and write it in the original form if you understand the reciprocal. I will also talk about this. When the power is negative, what do we do when the power is negative? But for now, if you get your negative 1 as the power, provided you've used the rows of indices, it is still correct. I don't know if that answers your question, Jace.
Yes, teacher, thank you.
So basically that is it. When it comes to division of numbers that have the same power, always subtract the powers. And I will give you, I have so many questions that involve this. That's why I'm not giving examples. I'm just going through these laws and we'll see the examples ahead. I don't want to get late. The other one is, if you have a number which has a power m, and they have put it in bracket and they have said it is to power n, those powers, all of them belong to this base. For example, if you have 2 to power 3 like that, then they tell you they have squared this. This power belongs to these 2 as well. So we get 2 and we multiply these powers to give us 2 to power 6. The power that has been put outside the bracket is powering this other number here. So we get what? 2 to power 6. Indices allows us to do that. This is an obvious thing. It may appear strange for those seeing it for the first time, but if we have a number like 5, maybe 100, 125, 125, like that, squared. This one means the power is for 125. When we remove that bracket, the power remains for 125. And remember, this 125 can also be written as 125 can be written as what in terms of base 5? 5 to power what? 125 can be written as 5 to power what?
5 to power 3.
5 to power 3. So this principle, number 3, says if you have 5 to power 3, which is 125 here, and they have put a power out here, this power is for this number that is inside here. So this becomes 5 to power 6, like that. It's what that principle means. We will see the application of this principle later on. So this is another very important principle. And if you're writing, can we have that added? You may not write down. If you have time, you can copy. I will post this in the WhatsApp group. Alternatively, you can take the screenshot such that you copy in your free time. Kanaga Junior, your hand is up.
Sir, okay, me, I'm asking, like, when 2 like 2 raised to the power 3 is the one like in the brackets, and then 2 is on top. Like 2 again is, should I say 2 is raised to the power 3 in brackets power 2.
Let me write that probably. 2
is raised to the power 3 in brackets power 2. Yeah, like do you multiply the 3 and the 2?
Yes, you multiply the 3 and 2. Now this 3 becomes your m. Are you seeing m here?
Yes.
Then your 2 becomes n, and the answer becomes 2 to power 6. I think that is
Okay,
it.
sir. Thank you, sir.
So this number 3 is very important, though not commonly said. This one is obvious. We assume almost every student understands that. The major ones are these ones I'm going to highlight in blue. This one and that one. If there is any question there, make sure you understand it before you get back to school. Otherwise, this one can confuse you properly. If we are multiplying, add the powers. If we are subtracting, if we are dividing, subtract the powers. It is not only that, we have so many of them, and I'm going to pick the other ones. The next ones are here. I am not sure if that is, yes, this is 3. Is here. Sorry about this. I need to cover this probably. I have to remove that. So the number 4 is here. If any number is to power 0, the answer is always 1. I think that is obvious. For those who have calculators, you can try. Any number to power 0, the answer is always 1. For example, 7 to power 0, the answer is what? You can put that in the calculator and you see if it can give us the right answer as 1. I'll later on talk about what that means mathematically. Has anyone confirmed that? The answer is 1 from Dorothy. Your name was who? I want to rename it here. Dorothy. That was Tracy. I am seeing some answers. 1, 1, 1. Yes. And don't cram. Can you put it in the calculator? Put 7 to power 0.
Easy, don't cram.
And you may make it a game that every time you see 7 to power is 1. It could be 8 to power 0. The answer is always 1. And the answer is always 1. Now, I want to put a point here. I don't know if you're hearing. You need to hear this very well. So, why is it that every number to power 0 is 1? That can be a question, a serious question. Mathematically, you may not see that as true. But when you put in the calculator, it gives you 1. You may not manage to explain that. That one means, hey, I don't know if someone is attentive here. Put yes in the chat if you're attentive. I need to know how many people I am talking to here. Some of you leave the phones there and go out. Yes, from, yeah, at least we have some yes in the chat. Let's leave the chat alone now. I'm talking about why is it that whenever you have a number to power 0 is 1. Don't write in the chat. You need now to concentrate. Those writing now are not concentrating. Eunice is the last person here. Someone should not write again. So, why is it that it is 1? For example, Becky, for example, 2 to power 0, the answer must be 1 still. And in most cases, we don't have enough time to explain that. But because this is holiday, you at home, you may need to understand this. How does this 0 come about? This could be maybe 2 minus 2, like that. 2 minus 2 gives you what? I think that is 0. 2 minus 2.
0.
Yes,
0.
it is 0, correct. You may not speak again. 2 minus 2 is 0. For example, I can write my 5 to power 0 as 5 to power 2 minus 2. I am trying to introduce a 0 here. 5 to power 2 minus 2 gives me 0. And for those who remember the laws of indices, when you see something like this, it means they were dividing numbers of the same bases. So every time you see a 0, just know they were dividing numbers of the same bases, but those numbers had the same powers. For example, 5, 2 minus 2. Those numbers had the same powers. For example, I can write 5 to power 2 divided by 5 to power 2. When I use my second law of indices, tells me that get 5, subtract 2 minus 2 to give me 5 to power 0. But ideally, 5 to power 2 is 25 over 25. The answer is what? 25 over 25. The answer is what?
0.
80. Do we have mathematicians here? 25 over 25 is 0. Okay.
So it's 1.
1.
So it's
Correct.
1.
Yes,
It's
you
1.
you have copied after copying. 25
No.
25 divided by 25, the answer is 1. And 25 can be written as 2 to power 2, 2 to power 2. That is why we have 5 to power 2 minus 2. And this one becomes 5 to power 0. Every time you see a 0, this is my point I'm trying to emphasize. Every time you see a 0 here, it means they are dividing indices of the same power. It has the same base, it has the same power. For example, 2 to power 1 divided by 2 to power 1. This is the same as 2 to power 0. Because 1 minus 1 is 0, and this answer is always 1. Because 2 to power 1 is 2, divided by 2. 2 divided by 2, the answer is 1. That's why it is written in indices as 2 to power 0. It means they were dividing numbers that have the same base and the powers the same. And when they subtracted, it became 0. It can be 100 to power 1 divided by 100. 100 to power 1 divided by 100, the answer is always 1. And where does the 1 come from? When you divide this in the calculator, 100 divided by 100, the answer is what? 1. And in index form, 100 is written as 100 to power 1 over 100 to power 1. And this becomes 100, 1 minus 1 in indices. Hey, now someone who is joining may see the blackboard is very disorganized here. May not even know what we are talking about here. So every time you see a number to power 0, just know it is coming from division, and the answer is always 1. I don't know if someone has understood that.
Yes.
We've understood.
Yes.
Okay. So that's why we have this principle here. It is too important. It is too important. And every time you see any number powered, for example, I'll give 25 here. 25 to power 0 is 1. Who can give us that answer?
1.
This is 1. Who can explain why it is 1? By show of hand now, I need to see. Why is it 1? Yes, Kanaka. Why is that 1? 25 to power 0 gives me 1. Why?
25 to power 0 is 1 because in indices, when you are dividing, we subtract, and we were subtracting from the numbers with the same base. So we subtracted and ended up with 25 to power 0, and any number raised to the power 0 is 1.
That one is a fair one. Fair, close to correct. But I want to hear the division thing. That is what missed out in your explanation. But still, you brought division of the same base. Can I hear from Hilda? Faith?
25 to power 0 is 1 because every time we see a power of 0, we know that they were dividing same bases, and these bases had the same power. For example, now, if it was 25, it was 25, maybe 25 to power 2, divided by 25 to power 2. So the laws of indices tell us that to divide the expressions with the same base, you subtract the power. So 25 to power 2 minus 2, which will give us 0. And if we are to use the other method, it will be 25 times 25, which will give an answer, divide by 25 times 25, which will give that same answer. And if we divide those two numbers, they will be equal to 1.
Correct. I think that one is correct, Hilda. Hilda has told me something here that 25 to power 2 divided by 25 to power 2 is 1, because if you want to use the other method she said, you can multiply 25 2 times, then you divide this by 25, also 2 times, and this 25 will cancel out with that, this 25 will also cancel out with that, to remain with our answer as 1. This is the longer way. Alternatively, you can use the laws of indices. Just write 25, which is the same base, you can see 25, then you get 2, take away 2 to give us 25 to power 0. And she has proven to us that every time we have 25 to power 0, it means they were dividing numbers that had the same base, and by coincidence, even the powers were the same. So majorly that is what I wanted to hear, and probably this explains why all the other hands went down. I feel she didn't leave any out. So that is a concept that is too important, just in case you have just joined. It is very important for you to know that every time we have a number to power 0, we are dividing that very number, and by coincidence, even the power is the same. So when you go to A level, they will explain this better using logarithm. It will be explained better using logarithm. I want to encourage you to do mathematics at A level such that you get to learn what we always left out in O level. So for now, take it like that. And the other one is that I want to clean here. The other principle is here, and it is every time you have a base raised to a negative power, then they have got it from the reciprocal. Every time you have a base which has a negative power, it means they have taken its reciprocal, and that's why it is a negative. For example, a to power negative n, it means it had a negative power. And that negative power, you people, comes because we are dividing. Now listen very carefully. The negative power comes because we are dividing numbers that have the same base but the numerator had a slightly bigger power, not the numerator, the denominator had a slightly bigger power than the numerator. That is what it means. But mathematically, we just say it is the reciprocal of the numerator. But it means literally that the power of the numerator was smaller than the power of the denominator. For example, if you have 5, if you have 5 to power 3, like someone had told us, and they are dividing it with 5 to power 4, the denominator here has a bigger value, a bigger power than the numerator. And obviously your answer will become a negative. So how do we get a negative? We get 5 to power 3, take away 4, and this becomes 5 to power negative 1. Yes, 5 to power negative 1. Every time you get a question or a solution that ends in a negative power, just know the denominator was big. And mathematically, they tell us that just get the reciprocal of this with the same power. So this can be written as 1 over 5 to power 1. Now, 1 over 5 to power 1 is the reciprocal power of 5 negative 1. If I gave you to write a half, the reciprocal of a half is written as
2 over 1.
2 over 1. I need to get that well. But in indices, okay, I'll explain why we get the reciprocal of that. 2 over 1 to power negative 1. Well, I've got it now. If you want to write this using a negative power, now let's listen here. If you want to write this using a negative power, get the reciprocal, which is 2 over 1, and tell the examiner that I got the reciprocal, and the reciprocal is denoted by negative 1. And 1 over 2 is a half. To power negative 1, you would have not changed this. It is the same a half, but you've reciprocated it, the reciprocal, which is 2 to power negative 1. How do you reverse this? How do you reverse this? You just get its reciprocal and this one disappears. So the reciprocal of 2 over 1, which is the power negative 1, its reciprocal is 1 over 2. Sorry. Its reciprocal is 1 over 2. So ideally, every time you get 5 to power negative 1, just get the reciprocal of this. Remember, there is a silent one that is seated here. The reciprocal of this will be 1 out of 5, like that. The negative 1 means the reciprocal of that. And I was telling you that this means that the numerator had a bigger value than the denominator. Sorry, the numerator had a smaller value than the denominator. And I will explain that using an example here. And the example I'm going to use is going to be the same example 5. I'm going to use an example 5 here, and I'm going to have 5 to power 4 over 5 to power 6. Who can give us that answer? That will be 5 to power what?
5 to power negative 2.
Yes, the answer will be 5 to power negative 2. And how do you get the reciprocal of this? It is the same as 1 over 5 to power 2. I don't know if you've noticed that. Is this correct?
Yes, sir.
Yes, sir.
The person who is saying it for the first time, I told you the reciprocal is negative 1. So how do you know that they have got the reciprocal of that? You write 5 to power 2 and you put the negative out. I think this one is more clear, such that it becomes 5 to power negative 2. There is always that reciprocal out. So how do you get this? You get the reciprocal, which is 1 out of 5 to power 2, which is correct. And every time you get 1 out of 5 to power 2, it means the denominator was bigger, and I'm going to demonstrate it using this very question. 5 to power 4 over 5 to power 6 is the same as 5 4 times like that over 5 6 times. How many times are these? 5. The 6th time is here. Now, if you're to use the method for cancelling out, dividing by, you realize that this 5 will cancel out with that, this one by that, this one by that, this one by that, and down you remain with 5 2 times, and that is what is remaining here, and that is what it means. But you can use the law of indices to go direct. So every time you get a negative power, the denominator was big, and obviously you always go back and write that reciprocal. And for example, you may get like 2 to power negative 3. This 2 to power negative 3, if you want to recognize the reciprocal, it is 2 to power 3 negative 1. So you just get that reciprocal. So every time you get 2 to power 3 negative 3, the answer is 1 out of 2 cubed, like that. So I felt you needed to know that, and I'm going to try to put random questions here, some random tasks. For example, 3 to power negative 1. How do you write that? Someone should put up the hand here. This is written as, yes, Patricia?
1 out of 3.
1 out of 3. Some other person should write for us 5 to power negative 4. This is written as, that is, someone should leave the hand up to write for us that. Shannon?
It will be 1 out of 5 power 4.
5 to power 4, like that. Someone can write for us 6 to power negative 7. Who else has not spoken here? People are not speaking here. Zenita. I've not even seen you here. Can you give us that?
It will be 1 out of 6 to power 7.
6 to power 7, like that. Basically, that is what that principle is trying to talk about. If there is any question, let me know. But for now, I feel there is no anything I can talk about here. So every time you see that, it means that. I want to cover this so we don't look at it so much. These ones will come later on. So I will assume someone has got that. Every time the power is negative, they had got that reciprocal. In most cases, if your answer is to power negative, go ahead and write it correctly like that. But if it is a fraction, this is what I want to emphasize. If it is a fraction, if your answer ends in a fraction, get the reciprocal and leave it the way it has been written. For example, if you have 2 over 3, like that, to power negative 1. If it is 2 to power 3 over negative 1, just write that reciprocal, and that will be 3 over 2. Maintain the same power, but with no negative, to be written like that. If it was 7 over maybe 8 like this, 7 over 8 to power negative 3 like that. Just get the reciprocal, and this will be 8 over 7 to power 3 like that. It's what that concept is trying to emphasize. Give it a lot of time such that you master it. Maybe I'm going to try a random one here. Someone to tell us the answer by show of hands. And I'm going to write 3 over 4. Someone should prepare the hand. Power negative 5. How do you write that without the negative? Sabrina?
It's 4 out of 3 into brackets to power 5.
Power 5. Correct. That is it. So continue looking at it until you understand it well. So I want to stop that from there and probably talk about the last one. And this one is when it is a fraction, but we normally don't talk about this so much. And I don't want to take a lot of time there, but I can quickly talk about what it means every time you have a square root, because some questions I have seen are complicated. If you write a square root, what does it denote? For example, 4 under root, like this. 4 under root means that you're writing 4 to power a half. I want to say that the square root is equivalent to a half. The square root is a symbol that was put, now I need some attention here, is a symbol that was put to represent an index power, which is a half. Because you cannot write a half. You see, when you are writing index like 3 to power 2, you saw it was obvious, we just wrote. But when it comes to fraction index or fraction powers, they have been given symbols that are recognized worldwide by mathematicians. Every time you see a root, they are meaning a power is a half, because some people may confuse. So why do you write 1 over 2 power 1 over 2? Just put that 4 under root and it will give you the meaning that the power is to power what? A half. So if you get 4 under the root like that, it means 4 to power half. If you get 4 to power 3, like 3 root like that, it means mathematically this one is also globally understood that every time you write that, it means this is 4, and this means that it is 4. The cube root of 4 is written like that. So it could be 4 to power 5, like this. 4 to power 5, I mean 4 root of 5 like that. This one means what? 4 is to power the root, which is 1 over 5. And not until the person made a generalization that maybe every time we have, a person made a generalization that every time we have a number under root, for example, 4 under root, the number that is here is always the fractal power, 1 out of n. So if this n is 5, just get 1 over 5. If this n is 3, just get 1 over 3. And when you don't see a value here completely, then just know that it's 2. We don't have 1 when it comes to this. When you see there is no value here completely, then that one is 2. So we may have a simple one, a quick one for a person who is following this, to try out. A quick one could be 2, 7, like that. This one is written as what? I need someone, and Patricia. This is written as 2 to power what?
2 to power 1 out of 7.
1 out of 7. The next person can write for us 3 root of 4, like this. This one is the same as, who is giving us that? This one, who is ready? Who is ready? Merami. That name there. That by
The
telling us
answer is 3. 3 to the power 1 out of 4.
1 out of 4. Correct. So it is very important for you to know that. And hope you remember our where we got a power outside, like maybe power 4 like this, but cubed out like that. Our answer becomes 3 power 3 over 4, like that. Because the power is outside, so mathematically they may trick you and give you something like this and tell you the root that we are talking about. For example, 3 under root for this, like this. I'm trying to write this. And they put that into bracket to power 7, like that. How do you write that? This one is the same as 3, 1 over 4, but the root is 7, the power is 7 out, and this one becomes 3, 7 out of 4. You will need this. I saw these questions also almost everywhere. And this is what is being explained down here. So you may have something of this nature, like maybe 2, 3 to power 4, like this. This is the same as 2, 4 over 3. Yes, this is what this Roman number 7 is trying to emphasize here. Make sure you get that. If you don't get that, find time and try to understand it. So I want to proceed to the next slide that brings the last principles. This one here is trying to emphasize that the square root of a is always a half. That means if there is nothing here completely, then it is meaning n is 2. Don't say it is n is 1 here. So that's why we have a half, like that, like that. This one is obvious. If a power m is equal to a power n, that one means these numbers are the same. For example, 5 to power 2. 5 to power 2 is only equal to this other number that is here if that number is also 5 to power 2, like that. These numbers are said to be the same if they have the same powers. If the powers are not the same, never say they are the same. And then if you're multiplying numbers, for example, 2 times 3, and they are telling us that the power is 2. The power is for both. So this is 2 to power 2 times 3 to power 2. The power is for both. Is what this is explaining here. So basically those are the fifth law. Someone has not understood the fifth law. Hope I go back there and try to talk about, always confused between a fraction and the reciprocal. The fraction and the reciprocal, I pray I get there. Okay, So later on, you'll ask me the questions in their order such that I understand which one I am to talk about. But basically, these are the principles, very, very important. Note them down and they will help us to solve. I have taken a lot of time explaining these principles because it is only these principles that we apply the other side. And I'm going straight away to the application. But if you have a principle you've not understood, prepare the question such that I can talk about it. But the major principles we're going to apply are only two, the first and second. And I'm going to display questions here. You'll try it in your book, put up the hand and tell us the answer. The first question I'm displaying is that, and you're supposed to, I want to cover these other ones. The first question is that, can someone put up the hand and read for us such that we confirm if people are still there? Just reading, you're not doing, just read for us that idea. I need to see hands that have not spoken here. I don't want to mention your hands. There are some of you who come and sit and you can't speak anything. Let me see who has not spoken here. Casey. If that is how they pronounce it.
The question is write the following expanded forms in index form. Roman 1, 5 times 5 times 5 times 5.
Yes, thank you, Casey. And the question is there. You're supposed to write that in index form. They have given you numbers that have the same bases. And write that in index form. Put up your hand, let us know. 4 hands are already up here. 1 hand has dropped. I want the hands of Martha. Martha has not spoken anything here. Martha, let us know of your answer.
My answer is 5 to the power of 4.
Let me put the answers for people here. Martha is telling us that the answer is 5 to the power of 4. Any challenger here? Who can challenge that answer? I see hands are still up. Probably these people are challenging that question. That is who. The hands are now down. It means that is the correct answer. Now, I want to emphasize that every time you see there is no power here, then it is 1. That's why Martha has just added the powers up here, and she has got 5 to the power 4. Correct. So, I want to display the second question. And the second question is here. Hope I have not removed that. Anyway, I want to display the second question. I didn't want to open all the questions. But let's sample out any of them. Let's do all of them. Don't do only one. I will sample one. You tell me the answer. But I think these answers are obvious. Who can give us the last one here? Give us this. This is Patricia. What is that answer? 7 to power?
7 to power 3.
7 to power 3, correct. 7 to power 3. And because the powers have not been indicated, then it is to power only 1. Kanaga, you have a different answer?
No, sir.
You want to give us what then? What did you want to say?
I wanted to answer that same question, but she has already answered.
Now that there is Roman number 2, can you give us that?
3 to power 6.
3 to power 6, correct. So that is how you write numbers in index form. Index form means you give it an index. And an index, I told you earlier on that index means a power. Able, you have something? Ebo, your hand is up. Is this hand really up or you forgot it? Ebo, can you go on?
I'm answering question Roman 3.
Question Roman 3, which is here. That is what? Can you go on? 2 to power what? Ebo, you closed your microphone. We can't hear you.
It's 2 to power 5, sir.
Yeah, 2 to power 5, correct. 2 to power 5. So if they ask you to write something in index form, that is what it will be required for you to write. Then the second task is here, and probably I should get ready to cover such that people. The second task, I'm going to display the second task. Get ready to give me the answers. We are going to try out the first and last for all the tasks, first and last. So task is here, and let's try out that. Who is reading for us? Who is volunteering to read? Just reading through. We need to hear someone read through. Patricia's hand was already up here. Anna, you can read for us that.
Write each of the following index forms in expanded form.
Number 1.
10 powered by 3.
Yes, proceed, Anna, and you finish.
Okay. 7 power 4 and 9 powered by 5.
So the questions are over there, and Anna has read for us the questions. Put up the hand if you want to write one of them. Give you a chance to write one of them in expanded form. They have given you the index, and they're telling you they are multiplying 10 these times. Put up the hand. One.
Sir,
Yes.
can I do it?
You want what?
Can I do it? Number 1.
That is who?
Desire, Agaru.
Desire. Okay, I had not seen your hand. Desire, you can go on. You're doing number what?
10 power 3.
Are you able to see a pencil on your screen such that you write directly on my screen?
No.
There is a pencil, look for it somewhere. Are you able to see?
Left corner.
No.
I'm told in your
Look
left
at your
corner.
left hand corner.
On.
Look at your left on the corner down.
There is a pencil.
Okay, she can't see the pencil. Desire, you can just read for us. I write for you.
It's 10 times 10 times 10.
10 times 10
times 10, which
like
is
that.
equals to 1,000.
Oh, 1,000. Now that is the expanded form. We don't write 1,000. We just leave at 10 3 times like that. So
Okay, sir.
I will assume that is now correct. The next person who is going to answer this should be able to annotate. I'm going to lower all your hands and give chance to whoever has seen a pen. If you've seen a pencil or a pen on your screen, put up your hand and try this out directly on my screen. Felista, don't first put. But Felista, you had already started even when your hand is not up, and that is not good. Probably who is here who has not spoken. Okay, Felista, you can go on. You're answering which one? Which is answer the last one? Okay, you answer that very well. Answer that very one. And we get maybe Kanaga. Kanaga, you can go on, answer the last one as well at the same time. So Ferista is giving us Roman number 2, and Kanaga is also giving us number 3. Same type, and all of them are correct. I'm waiting for Kanaga to finish. Yes, all of them are correct. Roman number 2 correct, Roman number 3 correct, and the one for desire, which I helped her to write, is also correct. If there is any question here, put up your hand. If I can correct it. I'm lowering all your hands such that I can have the hands up. I'm not seeing anything. A person using Infinix is not seeing anything. Galaxy S10 had the answer in the chat. Rachel had the answer in the chat. Martha had the answer in the chat. Galaxy 10. If you can give us your name, Galaxy 10, it would be very good. So, that is it. I'm going to display the next task here, and we see who can give us that answer as well. Like I said, we are going to concentrate. Galaxy 10 is who? Galaxy 10, you can type your name in the chat. I will help you to rename from here. Now, I'm going to display task 3. Get ready to see what the answers are. You'll put up the hand if you can write. If you can't write, I'll help you to write. Task 3, whoever is ready to read through, put up your hand and you read through everything as you give time. When you're reading through, you're giving time for your friends to do it. Get ready to read through. When I display to read through, as others are doing it, to give us the answers. Kanaga, read through that.
Write the following numbers in index form using base 2. I 8, II 32, Roman numeral 3 16, Roman numeral 4 64.
So Roman number numero 4 is read as what? You're reading I. That one is what?
IV.
IV. Where are you reading from? Anyway, those are Roman numerals, and she has read through that very well. Many people were writing at the same time. I had to close the annotation such that I can demonstrate the first one, what I want you to do. And those who will put up the hand, I'll open the screen for you to write number 2, 3, and 4. Get ready to put up the hand and do the remaining. So if you want to write the numbers in index form, but the examiner is insisting that you must use the base as 2. That one means you have to factorize all these numbers. In terms of 2, then you count the number of times 2 is equal to divide that particular number. So this is what I expect you to do. I expect you to do the following. For example, for number 1, now I'm putting it here. For number 1, it is 8. We want to write it in index form, but using base 2. So we get, we factorize 8. So by 2, the answer is what? 4. And by 2?
2.
2. By 2? 1. So this means that you write these ones. How many times has 8 been divided by 2? And that is 2. Give us 2 to power 3. And 2 to power 3 is the index form of 8 in base 2. I want to assume I am here. Someone should close for us that girl. I've closed the girl myself. And for those who have children, you're keeping children at home, hey, make sure you take them away from math, otherwise they may hate math up to when they get to secondary, which is wrong. Put for them cartoons to watch, not in the lesson. So I have factorized the 8 such that it gives me base 2. And I've realized that for me to get 8, then I will have to get 2 3 times. And my answer here becomes 2 times 2 times 2, like that. But because they are saying I write it in index form, I don't have to expand it the way I've done. I just write 2 to power 3, but the working is this other side. So if you're getting 34, factorize it in terms of 2. Tell me how many times it has gone into 8, or into 32. How many times 2 has gone into 32. So I'm going to put, someone already has an idea. I'm going to put a purple color here for a person who is going to do number 2. You're going to use the purple color here. That is enough. I don't know if that is enough for you. But let's not use colors. Just write anywhere. Who is doing number 2? I want to see new hands here. I'm seeing almost the same hands, which is not bad, of course, but we need some other person. Becky, you can go on. I'm going to open the screen for you to write. Becky, are you there, first of all? Okay, Becky, you can go on. Now, anyone else should not write such that we keep the screen as clean as possible. Becky, look for the pencil. Are you able to see it? Becky's microphone is closed. I can't hear if you're speaking anything. If Becky is not ready, can we get to Anna? Anna, using a laptop or a phone?
A laptop.
Go on and do for us number 2. For a laptop, you can use, that is Dr. Quincy. We will just remove you. If we give someone a chance and for you, go ahead and write. Let me start with warning this other doctor. See, you can go on. And I need to tell us what you're doing, such that the person who's prepared number 3 can pick the same.
All right, so I've got 32, and right now I'm kind of like factorizing it, something like that until I reach 1. So 2 divided by 32 is 16, and then 2 divided by 16 is 8, and then 2 divided by 8 is 4, and then 2 and 4 is 2.
And Anna, you need to put these lines. I'm going to help you to put from this side. It helps us to know. Are you continuing?
Yeah, and then I get 1. So now I count all the 2s which I have used. Okay, all the 2s which are in 30 is 1, 2, 3, 4, and 5. So it would be 2 times 2 times 2 times 2. 1, 2, 3, 4, 5. And this, now I'm going to write it in index form, okay? Now, since these are 5 2s, it will be 2 powered by 5. Yeah, that.
Okay. That is correct. Can you write the answer up there such that it's answered? If that is correct, Anna, can I get the next person to do for us 16? And 4 hands are up. I need to give chance to Martha K. Martha K, you can go on. Is that screen enough for you, or I have to create for you space?
Recording in progress.
So kindly request for space.
I do what?
Request for space.
Or you want space? Let me create for you space here. You're going to use this other side that I had used.
Okay.
I don't know if this is, I think this is not even good space. I need to give you the whole of this side. I use that side. I can't see anything. Are you writing, Martha K?
Yes.
Is anyone able to see?
No.
Which color are you using, Martha?
We are not seeing.
I'm using the pencil, but I'm also not seeing anything appearing.
You pick and select the right color. First pick, let me close the screen probably, then open again. Are you able to see the pen? I think no.
No, it has disappeared.
Then now?
I'm able.
And now when you click on that pen, select the color first of all.
I'm done.
Okay, go ahead and write. You can't see still.
A moment, please.
Okay, as someone prepares to help her, just in case she gets stuck there. Let's have our hands remain up just to be on standby. If she declares she's stuck, we get some other person.
Teacher, can I use the chat?
What is the chat? Okay.
Yes.
Okay, use the chat.
Okay.
Can we have Patricia go on to annotate as she prepares to post that in the chat? Because in the chat she has to type, then we post at once. If Phoenix Smart 6, don't write.
I do Roman 4. Excuse me, sir. Did I do Roman 4 or 3?
You do Roman 4 as she's doing Roman number 2 in the chat.
Okay.
I can't see anything. Patricia, you can go on.
So this is 60.
I'm waiting for Patricia to finish. Then there is another person trying it from the chat. Martha K. Whoever finishes, we will do that very fast. Patricia, you stuck?
Right, how to use a phone.
Okay.
Example
Krista?
number.
Krista, you can go on. Krista, you can go on. Krista, you do number 6, the one for 64. Let me add for you here. That is, someone is spoiling it here. 64.
So I'm using a phone.
You're stuck as well. Let me clean here such that we get a person who is using a laptop is the one now to do it. Even a phone can do, but let's get a person using a laptop. I'm going to lower everyone's hand. A person with a laptop and ready to do, you can put up the hand and do number 4. Ethan. Someone has suggested in the chat that we have the work in the group. We are going to post it in the group. Martha's done. Martha's posted something in the chat, at least. That answer is 2 to power 4. So Martha has told us the answer is 2 to power 4. Ethan, you can continue. The answer is 2 to power 4. 2 to power 4, which is correct. Anna gave us here 2 to power 5. I did this and the answer was 2 to power 3. I'm waiting to see what Ethan can give us here as his answer. And he's also trying to write very good work as well. We hope he gets the right answer. Ethan, you're not talking to us, probably. You need to tell us what you're doing. Ethan, your microphone is closed. Okay. Ethan, I don't know if you're still there, but this was correct. This is 1, 2, 3, 4, 5, 6. So this becomes 2 to power 6. 2 power 6. Yes, you can do it that way. And I don't know where Ethan has gone. If he comes back, he will tell us. Someone has told us time has gone. I am aware. This lesson is supposed to end at 4. I'm going to display some task here such that it can help us as an activity. Ethan, we want to hear you speak something. Later on, you'll need to tell us what you're doing. So I'm going to leave some work behind here in form of an activity. It will be task 4. Try to do it. We need to apply all these principles, the rules that we've looked at, to see if we can get the answers to number 4. It's a bit abstract, but I believe you will handle it. And if there is is telling us that 2 times 2 times 2, then the answer is 6 to the power 6. Correct. 2 to the power 6. I've already written it here. Ethan, have you failed to speak something? Anyway, so this is it basically.
So we get 64 and we divide it by 2 and we get 32 divided by 2. The answer will be 16. We divide it by 2, we get 8. We divide 8 by 2, we get 4. Then we get 4 divided by 2, it is 2. Then when we divide 2 divided by 2, it is 1. So then we collect all the 2's and then we express them in like in numbers with an index. So we get 2 times 2 because here there are 6 of them. So when we count there are 6, so the answer will be 2.2 power 6.
All right, thank you, Ethan. Kanakwa, you have something?
So for me, Ethan's tools, like when he was expanding, there are only 4.
That is correct. Ethan, can you add your numbers there? I think you didn't see that. Ethan, these are only good. 1, 2, 3, 4, 5, 6. I think Kanaga, you're now sorted.
Yes, sir.
Hey, now who has brought that wallet now? Someone has written here. So basically that is it. I felt you needed to hear about, for those who have not done indices, this is what you may find there in that lesson. And for those who have done indices, you're good to go. It's a good recall of what you studied. And I will be displaying the task number 4. If it's not very hard, we'll have to go to task number 5. We take it as an assignment. If it is a little well good, then you'll take it as an assignment. I want to display task number 5 here. Number 4, sorry. Task number 4 is here. And they want you to find the values. Find the value of the following index. Find the value of the following index forms. What is the answer to 3 to the power 2? You'll say 3 times 2 times 2 to give us the answers 9. They want the actual answers here.
9.
And this is enough for us. There are enough questions. Let's take a screenshot for that. Let me rename this to exercise such that we can take it as an assignment. For those who are taking screenshots, you may need to hold on. I have to take back this to exercise such that it can serve the right purpose. Exercise, and this is number 1. So there you go. It's number 1 and it has a number of Roman numerals. Let's look at 1, 2, 3. You give just the answers. What are the answers to any of those? And I'll be in the WhatsApp group to wait for your answers. I'm also going to post this same work on WhatsApp such that it can maybe help those who have missed to also catch up. Just give the answers up to the last one. The last one will involve you to recall the knowledge of reciprocals and 16/81. If you don't have that knowledge, it may be a little bit hard for you. Even this other Roman number 7, it needs you to rewrite 0.008. Maybe express this as 8/something, and then it will give you a better view of how to handle that number 7. And this number 8 is a bit obvious.
We are still copying questions.
Root to power 2. You know what to do here and you know what to do down here. So, what time are we going to send the work? Immediately the WhatsApp group is open, you just send. Alternatively, if you realize that the WhatsApp group is not open, then you might need to remind us to open. One of the administrators, just remind them that you have the work to post, or you can post directly to their inbox, just in case I forget to open, but immediately after here, I'm going to open such that you post it there. So if there is no any other question, I want to end the lesson here, and we leave the class a little bit open for about 1 minute, then I'll end it. Patricia?
Excuse me, sir. I didn't understand is it the 8th rule of indices?
8th rule of indices. Let me see. Hope I get it. But that slide number was what? Let me try 6. Is it around here?
Yes.
Which one?
Roman 8.
Roman 8 is here. Roman 8 is here. So probably, what exactly do you want to hear? Maybe an example. Let me try to demonstrate that somewhere here. This one meant those who have finished, we may not learn something else here. You're free to exit, unless if you're remaining here to ask a question, or if you still have time, you can hold on a little. But the lesson has ended, provided you have the exercise. You're good to go. But if you have a question, you can hang on a little bit. Roman number 8 tells us that if you have a number whose base is that, and there is a number whose base is that, and the power is here, these numbers are only equal if the powers are the same, is what it meant. For example, 5 to power m is equals to 5 power n, only if m is the same as n. I don't know, Patricia, if you're understanding the powers, m and n.
So m and n have to be the same powers,
even if
the bases are different.
No, the bases are the same. That's why we have a and a.
So the numbers have the same bases and also the same powers.
Yes, if they are to be the same. That's why I skipped these two. They are a bit obvious to students. The two numbers are said to be the same if they have the same base and the same power. For example, 5 to power 3 cannot be the same as 5 to power 2 is what it means there. You get 5 to power 3 is only equal to 5 if the power is also the same. You get it?
Yes, sir. Thank you.
And someone was also asking for something. Who was that? You can go on. In the chat, I saw some question about principle number 5. Let me see if I can get it here. Principle number 5 is here. But this one may need time. Is the person who asked for principle number 5 still on the call, or we? Let me see. Principle number 5. Who wanted to do that? I think the person is not here. That was Kanaga. The name is Kanaga. JR is for junior or what?
It's junior.
Okay. You wanted, but now that one, you need to be a little patient. But let's give it a try and see where we'll end. What exactly had you not understood here? For example, now my network will be on and off. I'm going to repeat that shortly. I'm giving this laptop time to get back, then we try that out. I saw the hand for Jen was also up. Hope she doesn't forget her question. My laptop is taking its time. Oh, anyway, let me give it more internet here. Jen, what was your question? Maybe as we wait for my laptop.
Recording in progress.
Then you can go on. You had a question. I saw your hand up. Is anyone able to hear Jen? She doesn't have a microphone. Sorry. That one will not hear us. So I'm going to explain Kanaga's question here quickly. I want to pick a board. I was saying here that for number 5, provided the base is known, like this, provided you see a negative power, it means the numerator had a smaller power compared to the denominator. And obviously, if the numerator had a smaller power compared to the denominator, when you're dividing, chances are so high that the value of the base remains down. So this one is written as a to power n. N stands for the number of the values that have remained down. I gave an example of 5 and we had 2 5s remain down, so it becomes 5 to power 5. And I also told you that in mathematics, anything to power -1 is its reciprocal. So a to power -n is the same as a to power n into bracket -1. So this is its reciprocal. The reciprocal of this bracket is written as 1 over a to power n, like that. I gave some examples and I said if you have, for example, 5 to power -1 is written as 1 over 5. And if you have 5 to power -3 is going to be written as 1 over 5 to power 3, like that. I don't know if that tries to explain answer your question. Does that try to explain, or you still want to know something? I'll try to add.
So it has explained.
Okay. Can we get the next hand if it's there? If it's not there, we stop this. Any other query? You wanted to know something during the lesson, but maybe time didn't allow. You can put it up. Is she even paying attention? No, she's on. So I want to end the lesson here, and I want to encourage you to be very good students always, and also remind you to always work for only 3s. Every time a chapter is introduced, look at how best can I get a 3 out of this chapter. So every time there is chance that the teacher introduces a chapter, look at how do you maximize to get a 3. And how do you get a 3? Go back to the lesson objectives. In that book, pick the lesson objectives, master all those objectives. The activity of integration always comes from the last objective. I don't know if someone had. The activity of integration in all chapters, in most cases, is set basing on the last objective. The last objective integrates all the previous objectives. So if you want to get all the 3, always look at the objectives and master all of them, but the last one, you must understand it. In most cases, the last one is the application of all what you have studied out. So can we get a volunteer to give us a closing prayer? And we go and do some other. A volunteer should put up the hand. That is who?
Sakanaga.
Go on, Kanaga. Kanaga, which school was that?
Indices S.
Go on there.
Let somebody also a word of prayer. Almighty Father, King of Kings, we want to thank you so much for this day and we want to glorify your name, Jehovah. You've enabled us to come and attend this lesson, Father, King of Kings. As you are going out, may you please enable us to do the activity and may you please enable us to go with the full swing of what the teacher has taught us, Almighty Father. Even to all those who claim they are slow learners, Almighty Father, I believe they have understood what the teacher has taught, Jehovah. As you are going to attend other lessons the next day and for all the weeks you're going to be learning, may you please enable us to take whatever the teachers are teaching us in order for us to progress in our examinations and the activities of integration. And may you please continue protecting our teachers wherever they may be so that they can be able to teach us again and again. I've prayed, believing and trusting in the mighty name of Jesus Christ our Lord. Amen.
Amen. We must believe in that prayer, and we pray that we all go well and come back well in the next lesson tomorrow.